from test 1? Yes, number 4 from test 1. 4, 4, 4. Oh, we did not discuss this yet.
Okay.
We shuffled subject topics around. This is for later in chapter 8. We're going to get to that. Sorry about that.
So it's not going to be on the test?
No, of course not. It's not part of what we discussed. Sorry about that. My apologies. Okay, anything else? If not, I will start picking some problems. If you don't have anything else for me from these 2 handouts. Okay, okay, let me ask. Do we need to graph the piecewise defined function?
Yes. Well, see, I can picture it in my head. I just can't write it.
Okay, let's not just do pictures in our heads, and let's put it on paper. So,
We did.
okay. Do we need to do it again? Okay, we want to choose another? Okay, so let's choose. Which one? No, I meant piecewise defined function. What if I show the one on the classwork from last time? Any of the 2? Because I wasn't very happy. Many of you got very good grades on this, but not everyone. So can anyone pick? Which form would you like me to work on? Blue or white? Blue. Okay, I have a blue because Dallas is not here. She missed this class today. Okay, so negative 2x plus 4 for x less than 4, and the square root of x for x greater to 4. Okay. So this is definitely a piecewise defined function. Let me emphasize one mistake that I saw as a common denominator, if you want, as a common mistake. If you remember the piecewise defined function, the 2 pieces cannot overlap. If they overlap, that is not a function anymore by the vertical line test, correct?
Yeah.
So one part of the graph has to be on certain x values. On other x values, a totally different part of the graph. And they cannot overlap. Is that clear? That's something to always remember. Secondly, how do I start? Well, I know how I start. I have to find the domain because I have to show some work. In order to show my work, I have to find the domain. I have to decide what happens where, right? So I strongly recommend change this into an interval notation. Again, if somebody teaches you a different method for anything, use it. If you understand it, I'm fine.
Just for the top equation or for both?
No, we're talking about an interval notation for this.
Okay.
Can anyone give us the interval notation for this? Good. So now the second one. You could teach this class.
Bracket 0. I doubt that actually.
Well, I could sit down and relax a little bit and you can do a couple of problems. Okay.
With some things.
Good. So now can anyone give us the domain of this function? I look here and I see from negative infinity to 4. Then I see 4 and I see everything from 4 to infinity. So what do I conclude? What is the domain of this function? Correct? Would you accept that? Yes? Good. Obviously, I have to write negative infinity to infinity in the chart. There is one x value that I cannot disregard ever in this problem, which is
4.
Do we all agree with 4? Okay. 0 also has to be in the problem, but 4 is the key. One more time. What happens at 4? That's where the graph breaks. One side will not be extended on the other side, and this side will not be extended on this side, right? So 4 is the key. So I see the open interval under 4 facing left, and I see the bracket under 4 facing right. They are exactly, both of them, exactly under 4. I saw that many of you did that, and you did a very good job, and I'm very happy to see that. Now I know this is an overkill, but bear with me. What function do I use for this piece? Remember, they may not be in that correct order if you want, quote unquote. They may be in a different order, so be very careful. So which function do I use for negative infinity to 4?
2x plus 4.
Yes, negative 2x plus 4. I know this is, again, an overkill, and it's very clear. I shouldn't even ask this question, which function I will have to use between 4 and infinity. The square root of x. Correct so far? Hi, Rex. So now, obviously, this is a linear, and this is square root. So linear, I plug in 0. What do I get? 4. Remember, I always encourage you to keep in the back of your minds, not just factor simplify, but also x and y intercepts. I'm going to add to that list of 2 action verbs, x and y intercepts. So now, obviously, if I choose 2, negative 2 times 2 will be negative 4 plus 4 will be 0. Every time I can, I will always find the x and y intercepts. Now I will plug in 4. However, I'm not really allowed to. So the point 4 comma blah will be an open point. The point 4 comma the other side will be a full point. They may be at the same point. They may be like this. One is open, but the other one comes in and closes because the numbers left and right are the same. But they may not be. There may be something like this. Open, closed. I don't know. So let's plug in 4. When I plug in 4, I get, yes, and I put it right here inside the parenthesis. So I know that 4, negative 4, if this number on this side is not negative 4, then 4 comma negative 4, will it be open or full?
Open.
Yes. If this number is still negative 4, there is no break in the graph there. So now I plug in 4 in this. And of course, I will also plug in 9. Some of you even got to 16, which was awesome. So, but that's good enough.
I actually
So,
forgot about 9 at first.
yes, Alex?
Can you explain that part again? The open.
So there is a parenthesis. I'm not allowed to plug in 4. So 4, negative 4 will be an open point.
But you still need to plot the point, but as an open one, not as a full one. It has every point up to, but not including that one.
Exactly. Yes. So now when I plug in 4, I get 2. 4 comma 2 with a bracket will be a full point, but 4 comma negative 4 will be an open point. I'm not allowed to plug in 4, but I have to plug in 3.9999999. But I don't want to do that. How will I plot it? Will be very difficult. So then I plug in 9, and the answer is 3. The only thing that I observed is that you forgot that the square root is not a straight line. So you cannot graph the square root as a straight line. Careful on that. Everything else was fine. So the first ordered pair from left to right, what will I have to plot?
0, 4.
Yes, 1, 2, 3, 4. It's in the middle. It's obviously it's a full point. Then,
2, 0,
very good, full point. And then
4, negative 4.
open, right here, open point. This is a straight line, no question there. I have to graph it as a straight line. If you remember, that is my next question. After I start and I created the chart, I'm asking myself, what am I graphing here? Oh, a straight line. What am I graphing here? A square root. So now, the next point from left to right.
4, 2.
4, 2. Is this a full point or an empty point?
4.
Yes, it is full. And the next one, so this was 4, 5, 6, 7, 8, 9, and 3. And I cannot graph this as a straight line because we know the graph of the square root of x. Can anyone give us the range for this function? I didn't ask for that, so I didn't deduct points for that. But can anyone give us the range?
Negative 4 to 10.
Careful. From the lowest y value till the largest y value.
Negative 4 to 10.
Exactly. Now I need what I have to put both left and right.
Parentheses.
Yes, Y parentheses on both sides.
You don't actually reach -4 quite.
Exactly. This point does not exist. So when x is 4, y is 2, not -4. Very good. Perfect. Anything else from the classwork that you would like to go back and see? There, just the last one, I think, or the previous one as well. I did not get a chance to post, but I will tonight. So please look at all classwork. Okay, next question. What would you like me to work on with you? Are we okay with the difference quotient?
Yeah, I am. Can you do it?
Yes. So from the classwork or for this one, which one? You can give me any one.
Classwork.
Okay. I only have blue. If you had white, okay, blue. Okay. So we have f of x, -2x squared plus 2x minus 8. And we're asked to find the difference quotient. If you remember it or not, it will be given to you. F of x plus h minus f of x divided by h. There are 3 pieces in here. 2 terms at the top and 1 the denominator. Which one I have to work on from these 3 pieces? Say it again.
X plus 8.
Yes, f of x plus h. Perfect. And then I'll come back to it. Perfect. So f of x plus h. Can anyone dictate what to write?
-2
Correct?
times x plus 8 squared
Yes, in parentheses. Very good.
plus 2x plus 8
Yes,
minus 8.
very good. Now what do I do next? I still have to fully simplify it before I put in the difference quotient. It's safe and wise to simplify it here than to write the fraction so many times. Anyone?
-4.
-2x.
Hold on. Why -4?
Oh, man.
So see, there is a product here, but -2 is not touched by 2 at the square power. -2 is alone waiting outside.
X squared.
Plus 2x
Awesome.
plus 8 squared.
Yes. Plus 2x plus 2h minus 8. And obviously I can distribute -2. -2x squared minus 4xh minus 2h squared plus 2x plus 2h minus 8. What did we say has to happen here? Every time for any function when I determine the difference.
You've got the squared on the f of x. Right? On the second half of the thing, 2x.
Oh, I didn't put the pieces yet together.
Oh,
No, not yet. Just 1 second. What has to happen in all cases in which I find the difference quotient? 2 things must happen, always. All terms that do not have h at the top must go away. What is the second thing that must happen? H in the denominator, that h in the denominator must go away. Indeed. Okay, so now I'm ready. I will continue from here, directly here. So this piece now is all this. I have to copy it. -2x squared minus 4xh minus 2h squared plus 2x plus 2h minus 8. Then, so I'm done with this piece. Now I'm here with minus to be distributed to everything in f of x. So what will I write?
Plus 2x squared.
Very good.
Minus 2x plus 8.
Perfect. So now as expected, terms without h must go away. Positive and negative. You cannot cross them out if they're not opposites, right? So, but if they are not opposites, something is wrong. So I have a -2x with a +2x and a +8 with a -8. Now I count the terms at the top because I can't miss any of those.
3.
1, 2, 3. They must have something in common.
H.
Yes. So I pull out an h. Remember, I cannot simplify h with h or something like that. Weird. Like I mentioned before. You cannot simplify a piece of a term with a factor. Good. So what is left at the top then?
Negative 2h squared minus 4.
So negative 4x when I pull out an h is negative 4x. Negative 2h squared when I pull out an h is only negative 2h. Correct? And then plus from 2h when I pull out an h, I'm left with 2. So that's how the h's go away. And negative 4x minus 2h plus 2 is the final simplified form of the difference quotient, which is the rate of change of this function at any point. Good. Anything else that you would like to go back to?
Can we do a transformation?
Yes. Any preference, or you want to work on this? This one. Very good. Good. So here it is. We have a function which is negative 2, the absolute value of x minus 2, and plus 4. We're asked a few things here. Domain range at the end. Domain we already know, but the range at the end. Then we're asked to find the x and y intercepts. Okay? And of course, present the steps, the transformations in order of operations. So let's start by finding the x and y intercepts, or domain first. What is the domain of this function?
All their numbers.
Right. This is indeed all real numbers. No headache, no problems. Good. How do I find the x-intercept of such a function? Or any function? What do I have to write? I have to write for any function. Forget about this. For any function, how do I find the x-intercepts?
So what is it?
Thank you. That's all I needed. Very good. Y is the function itself. Negative 2, the absolute value of x minus 2 plus 4 equals 0. I'm looking at this equation. I have to identify it correctly. What type is it?
Absolute.
Awesome. What do I have to do first?
Get the absolute one.
Right. Clean it up. Clean it up. How do I clean this up?
Subtract 4.
Very good. And divide both sides by? That's it. Good. So now it's completely cleaned up. Now I have to think. What number should I have in here so that the absolute value is 2? What can go in there?
4 and negative 4.
No, because 4 is the absolute value of 4 is not 2.
4 and 0.
You're way ahead of me. So x minus 2 must be either 2 or negative 2. I know what you meant. So now from here, then I know indeed that x must be, when I move 2 to the other side, 4. And from here, x must be,
0.
that's it. So what are the x-intercepts that we just determined for this function before we even graphed it? Very good. 0, 0, and 4, 0. Since the graph of this function passes through the origin, is there any point in trying to find the y-intercept?
Nope, you've already found it.
I already found it. The function cannot cross the y-axis twice. So I already have this as well as the y-intercept. Very good. Good. So now let's break this down into small steps. Which is the base function? And then graph them. which is the base function that was used. Before you answer, just you don't have to read it out loud, just read this to yourselves, and you will know which function was used to create this one. Which base function was used?
Absolute value of x.
Do you agree? That's what it is. There is no other function in there. Good. So the base function is the absolute value of x. Number 2, in order of operations. Let me write the function one more time here so we have it. In order of operations, what would be the first transformation that I need to apply to absolute value of x? In order of operations, just imagine that you are evaluating this function. Eddie?
Shift it horizontally
Shift it horizontally to the
to the right 2.
exactly. So if you were asked to evaluate this, like for example for 5, you will have to do 5 minus 2 first. Then you will have to multiply by 2. Then you will have to multiply by -1. And the last possible operation, you will add 4. It has to be, the sequence has to be in the order of operations. So indeed, x minus 2 means right 2. Then transformation number 3 is on function 2. It's no longer on function 1. This number 3 is on function 2. So what do I write? What is the next step? In order of operations. Yes, you can do that. I prefer doing 2 first and then -1. So see, when you multiply directly by -2. But there are 2 transformations in there. That's why we have to break it up into 2 steps. So to the absolute value of x minus 2. What transformation is this? Is it a transformation on x or a transformation on y? Yes, because it's outside. It doesn't touch x. So it's a vertical stretching by a factor of 2. Vertical stretching. Number 3. Oh, I'm sorry. Number 4. Number 4 is a transformation on number 3. And yes, we already know we broke it up into pieces. So now what transformation is 4 on number 3? Yes, reflect with respect to the x-axis. Final step is 5 on number 4. -2, the absolute value of x minus 2 plus 4. What transformation? Up 4. So the only difference is outside, not touching x, up 4. So on this test, I put several coordinate systems. You don't have to use them. So I start with the base function. This is the absolute value of x. Then you said right 2. Okay, right here. So this is x minus 2 in absolute value. Then you said vertical stretching. I'm not going to find points. So vertical stretching, obviously, by a factor of 2. Well, this point will move up here and so on and so forth. Well, this is a vertical stretch. So this one is 2x minus 2. Then you said flip it. Okay, I'm going to flip it. So this is -2, the absolute value of x minus 2. And then you said up 4. Okay, so here's up 4. So the green graph is the entire function. But now since I know the x and y-intercepts, I'm going to graph it one more time right here, anywhere, doesn't matter, with 0, 0, 4, 0, and 2, 4. And now this one is a perfect graph. Why? Because I used the exact, see here, I was just using transformations without really looking at points. But now I know this is the correct graph. And on this one, I can identify the range. What will be the range for this function? That's it, with bracket, because 4 is a full point. So that's the range. We have not talked about this, as I mentioned last time, not yet. It will come next week. We'll talk about that next week. Next question. Anything else, or I find something else to work on? So we looked at piecewise defined function. We looked at difference quotient. We worked on this problem. Any questions here?
I don't know the exact answer, but in my experience, I've gotten it right by assuming that if it's y squared equals anything, or the thing equals y squared, that it's not a function. I would say because in order to find it, you have to find the square root, which isn't safe, as you said, right?
Squaring both sides is not safe.
Okay, but
So,
square root is.
so we have to, when we are given a problem like this, we have to solve for y. So when I solve for y, since I have y squared and 3 plus 4x, I take the square root. So I have y, but remember it's y squared. So how many solutions do I expect?
2
Right, why? Because I have to really
plus
put,
or minus.
exactly. So plus or minus the square root of 4x plus 3. I put it in descending order. So obviously I got two functions. So the point I'm making is this. If I look at bubbles as we did before, and let's say I make x equals 0, how many different y values do I get when x is 0? 0 plus 3 is 3, the square root, but plus or minus. So I get the square root of 3 and negative the square root of 3.
So you get 2 and it's not a function.
Exactly. So obviously not a function. Why?
Well, you just said
Because we
it's a
said
solution.
a function is, the definition of a function is, for any x value, only one corresponding y value. Therefore, this is not a function. Okay, this was already posted because this is a problem we had. I copied it from here for the classwork, unless you have any questions on it. This we have not talked about. It will come in next week. This we have not talked about. It will come in next week. This, we did this problem in class. This is going to come in a little bit later, but this class. So I think this is done. Anything from test 1 that you think that we should go back to? Any of the problems? Maybe an absolute value inequality, or if not, I will find problems to work on. And I would like to work on this problem at the very end. Brian, which one? Do we need to work on 3? Any of the problems in 3? I know we did them together. I know we had similar problems on the class. See, which one? Okay, they are different. So maybe we should do both. Okay. So the first one is 1 less than 2 minus 3x. Yes, this problem is supposed to trick you a little bit, just a tiny bit. So if you remember, we have 2 possibilities for absolute value inequalities. This, where p is a number, or this. So I don't like having the absolute value on the right, because it's possible, could possibly make me make a mistake by not putting a correct order. That's okay. So I can read from here. So then I have 2 minus 3x in absolute value, and then exactly. Now I know which one it is. It's this one. It's the one that is more difficult. It's the one that it needs the union as the final in the final answer. Why? Because when I read it, it says this to me. Find these numbers whose distance from 0 is more than 1 unit. More than 1 unit. So then this changes into two totally separate inequalities. More than 1. So I have 2 minus 3x and 2 minus 3x. The first one.
Greater than 1.
Good. The second one.
Greater than -1. Less than -1.
Perfect. Is that clear? Okay, so now I know how to solve. I will subtract 2, negative 3x greater than -1. And then what do I do to both sides to solve negative 3x greater than -1? I will have to divide both sides by. Good. Right. Thank you. So I solved this one here. But I have to solve this one. Negative 3x, I subtract 2, less than -3. And then divide both sides by -3.
I'm acting like I'm deaf.
Good. I don't know sign language. Maybe I
don't know,
should.
I'm not using actual sign
I think
language.
I think I should know. At least a little bit.
Switch the side.
Good. So now please give me the solution. The solution must have the union.
Are you switching the signs because you're dividing by negative or because you're dividing?
Yes. Yes. So when I divide both sides by a negative number, I have to switch the inequality symbol. Yes. Let me give an example. Is 2 less than 3?
Yeah.
Let's say I want to multiply both sides by -10. This side is -20 and this one is -30. Can I still use this symbol? I can, because -20 now is bigger than -30. Good. So what is the final solution here?
Negative infinity 1/3. And from 1 to infinity.
Very good. Any questions here? Any questions? Is this okay? Everyone? Yes? Okay, the other one, the absolute value of 3 minus x over 3 minus 1 less than or equal to 3. What will be the first step? Say it again. So I add 1, right? Okay. 3 minus x over 3 less than or equal to 4. Now what? I can't touch it. I only have to think at this point.
You have two different problems now.
Careful. So I'm asked to find numbers. Which numbers? These numbers, whose distance from 0 is 4
Or less.
or less. So how do I set this one up? For 4 or less.
-4 is less than or equal to 3 minus the x over 3, and then is less than 4.
Yes, this is the nice one. Why do I call it nice? It's because I can solve both inequalities at the same time, which I cannot do with the previous one. Those have to be completely separate.
Multiply everything by 3?
Yes, but perfect. But I would like to get rid of this first, because I will have less to multiply.
Good.
Yeah.
Subtract 3, -7 less than or equal to negative x over 3 less than or equal to 1. So we subtracted 3 from all three sides. I subtract 3 from the left, I get -7. I subtract 3 from the middle, I get negative x over 3. I subtract 3 from 4 and I get 1. Final step. Multiply everything by -3. The left-hand side. Careful. Yes. The middle. Perfect. The right-hand side. Awesome. Now I have to think.
Flip the signs.
I have to flip the signs. It will make no sense to write that x is a number greater than 21 but less than -3. But now also I have to rewrite the inequality, reading it correctly. So it's -3 less than or equal to x less than or equal to 21. And this is nice. I don't have to intersect. I don't have to write the union because it's the intersection. I don't have to do anything. The solution is right in front of me. That's it. Very good. So let's work on the word problem. Any questions for me? Any questions for me? Please redo all problems we did in class. So we've done this today, but please go back in time and go over all the problems we did in class, please. Okay, the length of a rectangular tennis court is 6 feet longer than twice the width. So we have a rectangle, and we are told that the length is 6 feet longer than twice the width. If the court's perimeter is 228 feet, what are the court's dimensions? So how do I write what I have to write?
Length equals 2 times the width plus 6.
Yes, indeed. Length equals 2 times the width plus 6. So I will call this L and this W. So L equals 2, W plus 6. Okay, I need a second equation.
L times W equals P.
The
2L,
perimeter,
2W
yes, 2L
plus.
plus 2W equals 228. Perfect. What do you think, since you know a little bit about me already, what do you think I'm going to do to the second equation before I even touch it?
Divide by 2.
Divide both sides by 2. Always simplify to the lowest terms possible. So L equals 2W plus 6, and I have L plus W equals 114. Therefore, in the second equation, I will replace by, so 2W plus 6 plus W equals 114. I know how to solve this equation. The first step would be combine like terms indeed. So 3W, yes, and subtract 6, 108. And from here, I get W.
Divide by 3, and that is 36.
36 feet, very good. Is that good enough?
Just
No.
plug it back in.
Right here. So 2 times 36 is 72. So then the length will be
80.
72 plus 6,
Oh,
78.
Thought it was 8.
That's okay. So then we can go back and check. We have 15 minutes left. Allow me to choose some problems. So we worked on transformations. We worked on lines. We worked on, what about graphing a linear equation using X and Y intercepts? Are we okay with that? Or should I pick a problem?
Linear equation, I would say so. But then again,
Don't be shy. Is it a yes or a no?
don't take my word for it.
Do we need an example?
Sure. Yeah.
Okay, very good. So let's look at 64. On page 267, we are asked to graph. What type of equation is this? Say it again. Yes, but it's linear. Correct. So we're asked to graph it using x and y intercepts. How do I find the x-intercept? Awesome. Look what I do. How much is x? I have to move 20. Exactly. So x equals 20 divided by 6. I'll simplify by 2 is 10/3. Can anyone give us the ordered pair that we just determined, which is the x?
0.
Yes, indeed. 10/3, 0. The y-intercept. How do I get the y-intercept?
You subtract 6x from both sides, right? No. Okay.
How do I get the y-intercept? Set x equal to 0. So I have to find y. Exactly. What is the ordered pair that we just determined? 0, -4. And here's my graph. 10/3 is a little bit more than 3. It's kind of hard to plot 10/3.
3 1/3.
And 0, -4. Okay. Connect and extend the line. Always write the name somewhere. 6x minus 5y minus 20 equals 0. This is what we graphed. Okay.
We'll want our tests back at the end of this, right?
Those?
Yeah.
No, those are yours.
Oh, so they're just there for studying?
Yes, please.
Oh, good.
Yes.
That's what they were graded.
What if I am given a graph? Here's a graph. And I am asked, is this graph symmetric, or is this graph the graph of a symmetric function? Yes. What type of symmetry? Which means the graph is definitely symmetric with respect to the origin. Awesome. Okay. What about intervals of increasing, decreasing? Do we have to show that? Is that a yes? Okay. Piecewise defined function we did. Finding domain from a graph. We talked about that. Finding values of the function for a graph. No, okay. Identifying which one is a function, we just did that. Solving rational equations. Solving radical equations. I'm looking at the review on page for chapter 1 on page 213. Rational equations. Radical. Let's do a radical equation. Okay. Let's say number 11 on page 213. The square root of x minus 3 plus 5 equals x. What do I have to do first? First of all, what type of equation is it? Read it, not out loud, just read it for a second and say, oh, I know it's radical. Very good. So what do I have to do first? Say it again. Get rid of 5. Yes. So the square root of x minus 3 equals x minus 5. Perfect. Now, what do I want to get rid of? Hopefully, I can.
The square.
Awesome. How do I get rid of the square?
By squaring.
I have to square. How do I square?
By squaring multiply it by itself.
So the left-hand side squared, and how do I square the right?
FOIL of itself.
Okay, so you're saying we have an agreement, we will not FOIL, but the whole
Right.
thing is one unit.
Right.
Awesome, perfect. So then what do I get on the left?
X minus 3.
Perfect. What do I get on the right?
X squared minus 10x
Very good,
plus 25.
awesome. First term squared minus 2 times the first times the second plus the second term squared, awesome. Now what type of equation is this?
Quadratic.
Awesome, it is quadratic. What do I do? How do I solve this?
Quadratic formula.
True, but what will be the next step?
Factor. Oh, no, that would get us back where we were.
Combine like terms and set it equal to 0. That's my next target. Mandatory, right? Put everything on one side first. So I have x squared. I am bringing it to negative 10x. I am bringing,
11x.
indeed. And then I'm adding 3 to both sides.
28.
And if I forget the equal symbol and
0.
then I mess up the problem. Good. Perfect. So now what? Remember what I said, there are 4 methods. I will not complete the square, absolutely not. I will not take the square root because it involves completing the square. So I have 2 options, basically. If factoring takes this much, I'll factor.
It does.
It does. Otherwise, I will use the quadratic formula. So any suggestions on how to factor this?
-7 and -3, those are your numbers.
Careful.
7 and positive.
-4.
4, right.
Very good. So I have x
I had
equal.
4 in my head and then I said 3.
You're not the only one. I join you many times. So, x equals? Very good. What is that?
You gotta plug it in.
Because we squared both sides. Squaring both sides, cubing both sides is not entirely legitimate. So I go back with 7. 7 minus 3. 4. Let's go to 4. 2 plus 5. Would we accept 7? We have to accept 7. Now I will check 4. 4 minus 3. Square root of 1. 1 plus 5.
6.
What do I have on the other side? What do I have on the other side?
4.
Is 6 the same thing with 4?
Nope.
Will we have to do what? What we have to do with x
Roll it out.
out? X equals 4 does not work. Okay, do we need to work on a rational equation? We have 5 minutes left. Rational? Okay, let's do a rational. Okay, on page 213, let's do 19. Here it is. 2x over x squared plus 6x plus 8 plus 2 over x plus 2 equals x over x plus 4. And we looked at the linear inequalities and absolute value inequalities. We looked at other types of equations, quadratic equations, and what else was there? And 1, 1, what was 1, 1 all about? Oh, graphs and, yeah. We covered absolutely everything. So this is the last one. Okay, can anyone walk us through? Again, if you are using my method, I accept any method that works. Can anyone give us the factored form of the denominator?
X plus 2, x minus 4.
Plus 4.
Very good.
Very good.
Plus 2 over x plus 2. I like to bring the other one to the other side. And what do I have left on the right? Indeed. The next step must be stating restrictions. Can anyone give us two restrictions for x?
-2, -4.
Do you all agree with -2 and -4? So I don't forget, in case I get one of these two, I have to exclude it or disregard it. Would you agree? Okay, now I want the least common denominator, please.
X plus C.
5x -4.
I know what you meant. Today -4 is +4. Okay,
Right, right.
good. Adjustments, please. Can anyone tell us the adjustment for the top of the first one?
X plus 2. No, 1.
Exactly. The adjustment for the top of the second one.
X plus 4.
Agreed. And the adjustment for the last one.
X plus 2.
Good. Can anyone dictate the numerator?
2x plus 2x plus 8 minus x squared plus 2x minus 2x.
Perfect. What is the next step?
Combine like terms.
Awesome. So in descending order, please give me,
-x squared
that's it.
plus 2x plus 8.
Next step.
Just the numerator. Last one. Equals 0.
That's it. If I forget to write =0, I will never solve. This is quadratic. I refuse to solve a quadratic equation with a negative leading coefficient. What should I do?
What's all the signs?
Multiply both sides by -1. Factor form.
X minus 2, X plus 4.
Careful, because the sum is +2 and -4, and two options.
2, at -2 and 4.
That's why I did this. Is -2 acceptable?
Nope.
Is +4 acceptable?
Yes.
Thank you. I will see you on Thursday. Please come in early if